Give me a sec here. All right, so this is good. All right, guys. So again, guys, this is just some more practice. So if we go back to the question them asked, it's not beyond them to ask this question. They finish up here asking you. I don't think this is the end of it though. I think there's more, but state one physical property of C4H8. When they talk about physical property, again, what you understand from that term? Physical property.
Maybe how you look or you shape or you color or something like that.
Yeah. Yeah. So state, color, state. Let's stick to color and state. The simpler ones then the physical property. All right. So what could we guess here about this? Thing I give.
Are based on the number of carbons that it has. I guess it would be a gas at room temperature.
Yeah. All right, guys. Remember that in organic chemistry, for alkenes and alkenes, C1 to C4 are gases. All right. So this is for alkenes and alkenes. So yeah, these are typically questions they will ask. So all right. So this is actually gas. Them say one enough. So have others. What color you expect it to have? Were you told that alkenes have any color? You don't know what you were told. They are colorless. You weren't told they have any color, so they are colorless. Everybody get that?
Yes.
Yes, sir.
If they did have color, I'd tell you, say, look out for this color, but I didn't tell you that. So it's colorless. All right. So colorless gas. Physical property. Well, there are others too. Others too, you know. You could say low, you could have say low boiling point. But then they may higher order one them. The gas is the main one though. They might look for. All right. So that's that. And see them ask about what that's something to in the further part of the question. So them they move off of that now. Remember now they want to see if you lack of organic chemistry, just like what CXC is planning for you with those topics there. They want to see how much you know about it. So they'll ask questions about it. Coming like, you know, you do something wrong or somebody do something wrong, you are suspect, and them interviewing you here. All right. I guess the wrongdoings that you would be guilty of is actually paying for the exam. So you saying you want to pass it. Let's see if you got what it takes. Some rigorous questioning, guys, you know. They're playing good cop, bad cop here. Someone. But let's see what's happening. Ethanol reacts with what different reagents. So okay, I like this part. Different reagents. So ethanol reacts with different reagents to form products with functional group shown here in table 3. So what is meant by a functional group? See them find every little thing to define now, guys. You see them words like homologous series and you know structural isomerism, them where the functional group is. You can add that to the list. They will ask you these things. So what is meant by a functional group? All right. No. It's interesting though. All right. You know, functional group coming like no. It's like, yeah, go ahead. Shante?
So it's a group of atoms that indicate the chemical reaction or chemical properties of an organic compound.
Okay. That's some well eloquent there, man. So nice and well put together. But it's actually correct. All right, I'll just simply say that it's part of a compound which allows it to react a certain way. Okay, so it's part of an organic compound having the same reactivity throughout a homologous series. All right, so meaning that, and the functional group I was showing you now, and let me give you a more a visual picture. All right, here. All right. Super. It's just a part of the compound that allows it to react a certain way. So if you want to write it as that, yeah, but I want it to be more solid than that. All right. Interesting there. Functional group. All right. They have some very technical definitions here, which this exam is not about technical knowledge. It's really about understanding the concept here. All right. So no, not pleased with the definition for the functional group. Oh, well, yeah, I find a nice one. Lovely. This one is speaking my language. All right, let's put it here. You said. All right. What is in this?
Yes, sir.
Yeah.
Yes, sir.
Let's work with this. Functional group. Group of atoms within a larger molecule that that have. Oh, so they actually that has. So they are, let's say, having anyway. So all right. So it's a group of atoms within a larger molecule that has a characteristic chemical reactivity or part of the compound that reacts in the same way. I mean, you can simplify it. All right, that reacts. In the same way. Mm-hmm. All right, as a part of a homologous series. All right. Because where I would prefer doing it this way is that CXC, like when you use up the vocabulary, the keywords. So if you're gonna say part of an organic compound that reacts the same way as a member of a homologous series, then they would like you to make the connection between the words. So functional group is present in all of the series them. So if you make that connection, then that would please the examiners. And that's showing that you link things together. This definition here is a group of atoms within a larger molecule that has chemical reactivity. I mean, this is actually correct for definition, but in terms of understanding, you probably want something that you can relate to something else. So it's like you're defining. All right, so like homologous series, for example, one way you can define it is that it's a group of compounds having the same functional group and same general formula. That's a very what you call it now? That's a little hack in terms of defining it. That's a homologous series, same functional group, right? And then now, when you're defining the functional group now, you can go back now to the homologous series and say it's part of the homologous series that allows the compound to react in a certain way. So I hope that is making some sense to you, because that's how you have to group the definitions. All right. So they are all related. So, all right. So in other words, what we're saying here, the different groups where you have like the alkanes and the alkenes now, it doesn't matter how many carbon atoms them have, right? The functional group is in all of them. All right. It's just like you as human being. It doesn't matter it doesn't matter what race you belong to, which country you come from. There are just certain things that every human have that make you know so them a human. All right. I have never heard of a person confusing a human being with any other creature. Don't know if that has happened to you, but I've never seen two different creatures and say, oh, that's a human. That's not. It's, there's a different thing that we have. We would call that our functional group. All right. So take from that what makes sense to you, but that's the concept there. All right. So that's it. So I don't know that a human being could find another creature attractive in a romantic way. All right. I don't know if you believe the same thing, but I don't think that's possible. It shouldn't be. All right. The only thing, Jenna, you were saying something?
No, sir. I was just going to say yes, sir. That's true.
Hey, listen, guys. If you're studying the Bible, if you don't go to church, you'll hear something go on in the Old Testament. God had to lay down the law. There were men there who were going against what I just said.
All right. Where, sir?
Where? All right.
What are you talking about?
Talking about the same Bible. It's when Leviticus, Deuteronomy and Leviticus, the law had to be laid down because there was punishment for any man who look outside of the human race.
Oh, if you look on the Gentiles, like the Jews should not be with anybody else but the something else, sir. Only the tribes, sir.
So what part of the Jews would be like the functional group then? What would make Jews different from the Gentiles?
Because they were Abraham's seed, sir. God chose them.
Abraham's seed. Okay. So is it something that you can look and say, oh, that's Abraham's seed?
If you can just look at it and know, sir.
Yeah, can you look at a Jew and say, oh, he's Jewish?
Well, not sure today, sir. I'm not sure who is the Jew or who is not.
Yeah, because some of you probably might just be Jews, who knows? But the point is, the question I asked, I was hoping you'd tell me about circumcision. That's the functional part of a Jewish man.
Yes, sir. Yes, sir. True. Yes, sir. After 8 days, I think. Then I circumcised
I functional group that. All right, functional group.
And they shouldn't carve their head side, sir.
Right. That means you have to do no fade. No fading then.
Yes,
no fading of the hair.
Because back in the day, that usually represent as worshipping other gods, sir. So they should not have carved their head side. I either put on tattoo or wear like jewelry and something like that, sir. There are certain things limited to them.
Things here. All right, definitely. Certainly, that is it. That's like the functional group.
Neither should they build a statue or anything, sir. So you must know a Jew, because they're just totally different for everybody else.
That is how we identify functional groups, right? Part of you function differently. Put you in one different class or different group altogether. All right. So but guys, as we say, some people say they have to go class go on, but as we say, race is not for the swift though. I'm doing to the end though. But this functional group definition, guys, as we say, the key word here is the same same reactivity. Or you could say group of atoms, same reactivity. All right. Let's write that. Just to be thorough. So yeah, atoms, I could say group of atoms. All right, in an organic molecule. All right, having same reactivity. All right, and then we could add no longer series. Yeah, again, many ways to define it at 60 level, but any questions here, guys?
No, sir.
All right,
No,
Kimmer is
sir.
still here. DHNL, you there? Okay, saying no question.
Yes, sir.
Casey, you still there?
Yes, sir.
Deborah, you gone?
No, sir. No, sir.
Okay, all right, still there. Lovely. Sashay, Michaela, and Danny. All right, sure you're still there. All right, very good. All right, functional group, that's out of the way, guys. And then now, them say complete table 3 by identifying reagents. Now, this, I think, okay, so it's on the outline. It's on the list of topics there to talk about the reaction of the organic compounds. Now, this could be alkanes, alkenes, or alcohols. Most likely those 3. All right. That's where a lot of reactivity can take place. So now let's dive into this matter here. Complete table 3, identifying the reagents and or reaction conditions. All right, so let's go now. Ethanol is given over here. Let's try to understand this. And them say part B said draw fully displayed structures of these products. All right, guys, as we say, this is a bad cap question, guys. The CXC people them want to prove, words to them. So ethanol is here, functional group in product form. So well, something happens to ethanol and it turn it into an alkene. I think I went through this last class now. I just barely touch it, but I go through it. There's something I can do to ethanol to turn it into an alkene. All right.
Yes.
So what is that? Somebody remembers that? Okay. It's interesting. All right. No. Yeah. All right. I want to show you this image. Although this is I remember showing you this though, but because you guys forget, I'm gonna have to show you again. But this time I'm going to try and use an image here. At least something that looks like an image. All right. Let's get this picture up, guys. It's actually a diagram more. Everybody seeing this?
Yes, sir.
Yes, sir.
All right. So as a rule here, all right. Never mind this second degree and third degree thing. That when you go after CXC, you're gonna learn say you have different degrees of alcohol. All right. You have primary, secondary, and tertiary. So that's why they put the degree there. But at CXC level, we just concern say when you have an alcohol, as a matter of fact, let me crop out that part there because we don't need that part. Yeah, there you go. This is the simple rule you're going to need to remember. you have an alcohol, you add some heat to it, use sulfuric acid, you turn it into an alkene. All right. No, this is the you call it no. This is the line in the American center use this a lot too. Instead of drawing out the entire compound, you see them have a system of lines we then use. So yeah. So then that's how they end up with this now. All right. So anyway, this now, as you can see, the alkene they show the double bond here. So, but then let me just put it in the way that you know it. Here we will look like this, and that's what it comes out on the CXC paper. And the alcohol, the functional group for the alcohol, that's why they kind of warm me up to the functional group. The alcohol always have OH at the end there. And then of course, this is the functional group. So them just showing the functional group here. When you add heat to it, somehow something happens to this functional group. Actually, the heat will remove the OH and the H and it form water. And when you remove the water from an alcohol, you get alkene. So that's it. The H2O is formed from the OH will come off and the H. All right, so this is from the functional group. All right, notice that the functional group in the alcohol is reacting. All right, it is absorbing the heat and then also reacting with the sulfuric acid here and then forming the alkene. All right, so now let's go back to the question. And we're seeing that ethanol, the functional group in product form, is the alkene. What are the reagents and the conditions? 1 mark, so you put any one of them. So in that image that you just saw a while ago, what 2 things you saw? What 2 things were happening to the alcohol before it became an alkene?
It was heated and sulfuric acid was added to it. I
Very
think.
good. So yeah, that's the answer that they want here. All right, so heat, and they say 1. So you can put heat or H2SO4, which is the sulfuric acid. Any questions here, guys? So remember now the question is really asking you, and they put it in a table form. But it for a student who is unprepared for exam, this might be a lot for them. But now you're learning that they have done it before, so you are being prepared now for what may happen on the paper. Whichever way I can't really say for certainty, but what I can definitely say though is that they will try as much as possible to go to familiar questions. So it is looking as if the past paper style of questions, one of them will come. So they're not gonna play any tricks on you in this COVID here, because they realize they don't really get no real school like how they normally get. But saying that to say though that any one of these past paper questions could turn up, so we have to take them seriously and go through them with detail. So the ethanol now converting to the alkene. By the way, the ethanol is an example of an alcohol. So this is just one example. The alkene form in this case would be ethene. If we use ethanol, we'll get ethene. So that's how it works. All right, anyway. All right, now the structure of the organic product form. I did structure them showing that if it's ethanol and then it go through this, what the structure of this ethene would be. You see, if you write ethene here, so you already answered this question, you know, or them just you partially answered, because them say this ethanol will convert to an alkene. But with your knowledge now, students, you're going to say, oh, well, ethanol is an example of an alcohol. Alkene is the name of the group that will be formed. However, if we are using ethanol, which is 2 carbon atoms, then it's going to form an alkene with 2 carbons, so it's going to have the prefix eth, just the same. So remember, guys, ethanol can form ethene. Everybody see that?
Yes, sir.
All right. Ethanol forms ethene when it is dehydrated. Just add some heat and add some acid. You get that going. Structure now. They simply asking you what is the structural formula for ethene. And everybody should know that. 2 carbons with a double bond and 2 H's, C2H4. That is it. In fact, they just put some H's on what them draw here, so I'll show you. Any questions here, guys?
None, sir.
No, sir.
That's it, no. You have your acid there. You have your reaction lesson now. All right. So something happens now to ethanol to convert it to an acid. They're asking you for the conditions and the reagents necessary. Now let's go this way. I did show you this before. It was yeah, I did
That's
send.
carboxylic acid.
Yeah, well, definitely this is the acid. But I did show you a diagram at the start of last class where we said CXC will ask you questions most likely there. Right? So only if you go over the notes, it's there. And like I said is that I was telling you the story of with the rum, and say when the rum spoil, it form vinegar. You know.
That's why I have that scent there, sir.
What that?
That's why I have that the scent there.
Yeah. So yeah. So you have your sugar, you do your fermentation, it form alcohol. Let the alcohol stay too long, it convert into acid, which the acid formed from sugar cane, rum, is vinegar. So that's the story. So now, but the question is, what conditions are needed for that? So let's bring up another visual here. As a matter of fact, there is an intermediate stage, but I want to find the simplest diagram to show you what on earth happens there. All right. You have so many you have so many models here for this though. But yeah, I'm gonna get this one. This is the simplest one. Or is it? So then there's actually more to the story where the alcohol form acid directly. And this is the story here. It goes through it forms something else before it goes directly to a acid. So you can't just move from an alcohol to an acid straight away. It have to pass through a little intermediate stage. All right, that stage now is what I'm going to show you in a second. Right here. And here it is, guys. Everybody seeing this?
Yes, sir.
Yes, sir.
All right, so the progression here is that you have your alcohol, of which ethanol is an example of it. But alcohols, this thing is the conditions right here. So it's the conditions. All right, our conditions necessary for this to happen. You must have these two things. Now, notice that in both cases they are the same thing. So why at CXC level them not really tell you say it formed this intermediate thing? Is that, well, one, they don't want to make your life learning organic chemistry too difficult. They just want you to forget about this part. All right. And just imagine say it goes straight. All right. The only thing you need to remember to convert from alcohol to of course this would be alkanoic acid, also known as, I get used to these names, alkanoic acid, also known as carboxylic acid, which that's that molecule at end with the COOH there. Remember, this part will be the functional group. All right. This part now, guys, is you just need to remember this word. K2Cr2O7. Of course, the H plus mean acid. So we really need an acid. Usually sulfuric acid. They didn't ask for the specific name, so let's put acid there. Make it simpler for you to remember. But this K2Cr2O7 is known as the K stands for what? Well, it's there. What the CR stands for?
Pro.
Well, yes, the derivative of chromium, but actually it's going to be potassium dichromate. Actually, it's 2 chromium. But then remember that whenever a compound or whenever element form like an ion with oxygen, it always end with 8Te. So chromium 8 the oxygen and end up with potassium dichromate. So that's the name of the compound here. Potassium dichromate, you need to remember. This is an orange powder. You guys ever seen anything orange in the lab? That's the only thing orange we use at CXC. Only orange compound we use at CXC. All right. This is important. If we were at class face to face, we could show you that. But one of my favorite compounds though, because this is what dichromate looks like. This is what you add to the alcohol so it can change into an acid. All right. So this is what it looks like, guys. All right, potassium dichromate. Everybody seen that?
Yes, sir.
Yeah, that's definitely that orange powder used to convert the alcohol to the acid or the organic acid. All right, potassium dichromate. So this is what you're going to add here. Also, why we usually add this is that whenever you have your alcohol, you put the potassium dichromate in there. It with the acid, it's gonna change the alcohol. Well, it's gonna change the color of this dichromate. The alcohol will make it orange, and then when we put dichromate in there, we put in some acid with it, it will actually change to green. That's when you know, say you have your alcohol forming. So it's actually a little test. And I think that's what they're asking about in this question. If we go back to the question now, guys, they really want to see if you guys also the labs. These people are really pressing your hard here for answers. So the alcohol to the acid, them asking you for the reaction conditions or the reagents. So the one answer then they went put here. So I remember that new compound, the orange compound, it's actually this compound. So I'm say potassium dichromate. All right. That's the way you change from alcohol to organic acid. All right. And them draw the structure here. So you don't have to do anything here. And notice here, so it's a functional group. All right. This is the functional group for acid. All right. All right. And then I finish with it again. Then I finish with it. You see, then give us only 1 mark here, so then say, all right, give them one mark here, so cause everybody are gonna know them, yeah. But if you're really going for grade 1, here are the questions. If you're going for the grade 1, here are the questions. Then give you COO, and there's a R there. All right. No. I remember I gave an outline for this. I just don't remember where those notes are on my thing, but I know I did it. It's list no somewhere there. Yeah. Question is, how can you convert an alcohol to an ester? Again, showed you this before. Say that whenever you react an alcohol with an acid, you get an ester. So That's the answer here. No, they're asking you for the conditions here. All right, so now what conditions? So what reagents you need then to get the ester? Well, you're gonna need 2 reagents here. All right. One is that if you have a alcohol, you first of all need the acid. All right, and to reach this ester here, you're going to also need some. This one is very popular. Sulfuric acid again. I can tell you this, guys. Sulfuric acid, you can't go wrong with sulfuric acid for the conditions here, because even with the second one here, so the potassium dichromate, you still are gonna need some sulfuric acid here too. So this thing is very common. So if you're in some doubt or something there, once it's organic chemistry, you convert in anything. Sulfuric acid is is the most common thing used here. All right, so these are 2 marks you will get for the reactions here. Of course, you're gonna need liquid heat as well too. So you definitely need some heat. But 170 degrees, you get that. The structure of the organic compound form, which I'm gonna press it hard here. So anyway, I'm just going to do this and finish it. All right. If you have all right, let me even draw this part and show you still. So basically, when you draw ester, guys, it is basically the acid reacting with the alcohol. So what you do basically do here is just do this. All right. And then you do that. And then of course, usually the mango here, so still all right, for the formula for ethanol is always C2H5. So this part now is the ethanoic acid part. So let's write the name here. So ethyl ethanoate. All right. Which alkanoic acid you're going to need though? We have to be specific here. So definitely to make this, you're going to need ethanoic acid. Remember, anything with EH means a 2 carbon in there. So that's why we still keep the eth there. Eth, 2 carbons here. All right. So that's pretty much what they're looking for here. Grade 1 territory here when you reach the last part here. For the last 4 marks, this one come from really understanding this stuff. And but you still will get 11 out of 15 for the basics here and these things before. All right, any questions here, guys?
No, sir.
Yeah, all right, guys, this is it, I mean, this is it. For the last few days, we're trying to nail down organic chemistry here. And so these are what the questions, can look like based on the topics I'm saying. So guys, as we say, you have to go through your information. All right. So did you guys learn anything tonight?
Yes, sir.
Okay. So Kimberly learned something. That means say.
And I said, of course.
Yes, sir.
Oh, okay. All right. Make sure. So as we say, guys,
Sir,
recapping.
on a scale of 10,
Hold
I
on.
mean 5, on a scale of 5.
You still at
Sir, on a
5?
scale of 5, I'm about 3.
What are you talking about? The topics, them?
So yeah, asked if we learn anything, and I'm saying on a
Mhm.
scale of 5, I'm the 3.
All right. Well, that's going somewhere. That's progress still. All right. So the issue is still there. Somebody come off. The issue come off. Oh no, you're still there. The issue. All right.
I'm still here, sir.
All right. The issue. Now tell me all right. Which topic this will come under? Just check in there. You say 7, 6 and 7. Tell me 6 and 7 again.
No concept.
Hmm.
6 is sources of hydrocarbon compound
Oh,
and
so
several organic chemistry.
oh, okay. And 7 organic chemistry, and then 8 hour.
Reaction of carbon compound.
Reaction of carbon compounds. All right. So this cover some of that. You cover some of that. We see when they put organic chemistry now, they don't have they don't have anything in the bracket there, Chanel.
Yes, sir, they do, but
What
sir,
is
I
in?
don't understand them right.
Oh, I write it down. I forgot
Yes, sir.
in the group we find where that thing we sent to now. All right. I'm trying to chemistry group there. Can't find the chemistry group. Oh, see it. All right. That was oh yeah. Yeah, man. This was there. All right. So I'm seeing it here. Source of okay. So the organic chemistry here, them say an introduction, them say. Introduction, them say. So for the 7th topic, them say it was an introduction to organic chemistry. So that is alkenes, possibly isomers, possibly alcohols there. Reactions of carbon compounds, most likely alcohols there. There's also another type of question they could ask you where how alkenes react with even chlorine and those things. They didn't go there in this question, but they have gone there before. So until we cover all of those bases, we still have to be working on these questions. All right. So I think as far as the sources are concerned, you guys should have a basic knowledge going in. Sources, the crude oil and natural gas, and they want you know, like, as we say, the distillation process and the cracking, those terms here. Once you know about that, and they ask about physical properties of them and so on, you're good to go there. And then they want you know about alkanes and alkenes in detail, usually structural formula, isomerism, things like that. And of course, I'm going to impress you for some reactions as well. So as we say, reactions are basically the same reagents used. Just get more familiar with it. And then, of course, the alcohols and the acids and the esters. That's where they'll go, the reactions. All right. So potentially, this is looking. Could this be a 15-mark question with all of those? It's very likely. It's very likely that you will get 15 marks from them, maybe 5 marks from each, from 5 marks for topic 6, 5 from 7, 5 from 8. And then basically kill you with something else now up top, which is electrochemistry. They have to do with electrolysis. So we have some work to do there, guys, for electrolysis. I have a lot of work to do there. I wouldn't say a lot though, less than for organic chemistry, because I want to learn little electrolysis already. Just didn't teach you the calculations. All right, so just that leave for electrolysis, and then some acids and bases stuff there in the mix. So we have work to do, guys. Work to do. But as we say, if with knowing organic chemistry, that's a big thing going into the exam. So let's try and go over those and stay focused with that topic for now until now start going to the other areas. All right. So, all right, guys, that's it.
Yes, sir. Before I go, sir, can I show you my screen? So I want to ask you. Sir, could you explain what is manipulated variable and responding variable, please?
All right, so that we carrying back to the lab here. Manipulating variable, it would be here. The manipulated variable. As I keep on saying that the manipulated variable is the variable that you are going to adjust, and you are going to be in control of it because you are the man, no so you are the man, you know. So you're going to manipulate the variable. So that's how it works. All right. So now, which one of these now? And I'll give you some examples here. As the man in the experiment, which one of these you're going control so that something will respond. When you look at the responding variable, if the aim is to produce a sample of alcohol, right? If your aim is to produce
Yes, sir.
right, if
My
that's your
aim is to make a new recipe for whiskey, sir.
that's not the
Based
aim.
on-
The aim is not to make the new recipe. The aim is to produce an alcohol. The title of this lab is fermentation. So this is the example of the aim. It must have you producing the alcohol. So a proper aim.
Sir, I did write make, sir, to make.
All right. Yeah, you can say to make. Yeah, that can work. Make or prepare. All right. All right, a sample of all right, sample of alcohol from whatever source. Whatever source you're going to use.
From Oakwood, sir, I use.
Oakwood.
Yes, sir.
Why? You're brave though. Gone. Would you go use make this one? So hold on, you know. Oakwood. You have Oakwood.
Well, not really, sir.
So all right. All right.
I can get some though, sir.
You gonna get some. All right. All right. So Oakwood starch. Well, this is brave. For all the things in Jamaica to use, using
I
Oakwood, but
use ethanol. I use ethanol. A tablespoon of sugar.
use ethanol.
Yes, sir.
You can't use ethanol. I eat you gonna make. Fermentation is the conversion of sugar into alcohol. So you have to use something like starch to form alcohol. You can't use ethanol. Experiment dead if you use ethanol.
Yes, sir.
So the yeast you have to make the natural yeast them convert the starch into alcohol. If you put alcohol into it, then they going to poison the yeast and then there will be nothing taking place. So no, so you have to use. So prepare a sample of alcohol from Oakwood starch.
Sir,
Yes, go ahead, Deborah.
I have a question.
Yes.
You know
go ahead.
anywhere in Mandeville that I can buy yeast?
Yeah, man, supermarket. That's in a Super Plus. About 5 bills fee.
Okay.
Yeah, man. So because I see him yeast where you use make bread, you know. Where people make bread out of them yard, you can
Pudding,
use the
sir.
same yeast.
I think so.
Or pudding, yeah. Anyway, they use really? I've never used yeast in a pudding before.
No, they don't need yeast for pudding.
Oh. Well, yeah, in the kitchen you can use baking soda and
Yeah, it's
baking powder really, not soda. Powder. Soda
Some
probably can't
baking
use.
stuff use baking soda.
Baking soda?
So,
Yes,
sir,
sir, some things require baking soda.
Okay. Yes, Casey.
don't we carry out the lab?
No,
Oh,
but we are discussing it as if we are carrying it out.
okay.
Yeah. If you want to carry it out, you carry it. More marks. Remember, one of them you have to carry out. I don't know which one to not carry out. All right. So, sample of alcohol from Oakwood starch. That would be your thing, January. In terms of the variables there, the responding variable is the production of alcohol. So, definitely alcohol formation would be responding, but in order for you to make this be the response, you have to give it the right stimulation. And that's where you as the man come in with the manipulation of something. So what will we keep constant though? Certainly
The oak. Come
the awkward. All right. No, that are gonna be you, or that you are gonna use as the man. You are gonna use the awkward that are the manipulated.
Yes, sir.
Awkward starch. I don't know. I'm gonna say you're taking a leap of faith here, Janari. But may God go with you. Not saying it can't work, but it's brave. All right. I believe it can work, but sure. On a university with it, so I even appreciate. But control variable. Control variable are these, Control are the fixed ones, This is fixed. Control means you basically fix this.
It remain constant throughout.
Yeah.
Same.
Yeah. So the temperature have to be the same or constant. Yeah, you have to control that. I think keep that
Sir, yes,
control.
sir. I would use oven and hot water, sir. Pour on the
Oven and hot water. Don't it. Weird though. A cook or yard ferment. Me not understand what you do,
No, sir.
Where I go use oven? I mean, you lock it in an oven.
No, sir. You go throw it off with hot water, sir, and then you rinse off it, sir, and then you go put in the oven, sir.
That's weird.
Let's go to the whiskey approach here. Let me see if we can confirm this thing. All right. Is this the method they plan to use, January? For whiskey? Like how them do it in the Middle East. Get the grain.
There's boiled water in there, sir. I wasn't going to use grain though, sir, but I was going to use the boiled water distilled and the oak.
Mm-hmm. Right.
And in a container, sir. I was going to use the container also. And the water, yes, boiled water and water, sir, also.
So
After I told you, you throw hot water on it, and then you throw off the hot water, you leave it for about 12 hours, sir, then you throw off your hot water, and then you pour, rinse off with water, sir. And then after that, now you take it out and put it on a tray, sir, and put it in the oven, sir. That's it, able for,
that can work. Yeah. That can work. That can work. Just to see what you do this. So. All right. So that part will work. So when you go right in the method, then you get the grain, you get the water boil and whatever. But at the end of the day, you want the water at 37 degrees, right? Or somewhere near there. So all right. After you get the warmish water with the oak, and you cover it, you have to seal it tight in a container.
Yes, sir. I was going to use a jar container, like.
All right, you use a jar, but then before you even seal it off, you have to go put in the yeast in there. So really and truly, you're gonna need 1, 2, and 3. All of these 3 things are go into this.
Yes,
and
sir.
you're gonna seal it off tight. Make sure so no air can escape. Make sure so no air can escape.
And a little bit of sugar, sir.
Well, yeah, because oak would not have enough starch, so you have to go drop in some sugar just to get it started. That's why they call it starter here, so yeah, forget it started. Like sugar need in there. Well, I'm just say it if it work, it work. But then you probably not carry it out still. But I mean, marks for effort, so can say get all of the marks just the same. So yeah, that can work now, January. So your variables them are here. So you can watch back the video and see it then. Of course, control variable here. Of course you're going to have your airtight container as well, but certainly the yeast will be constant. These things will be fixed. Temperature and yeast that have to fix. Yeast them not gonna work outside of a certain temperature. All right, so your variable should look like this. All right. So So that's it. So any more questions, Janari?
Sir, I think that's it.
All right. So you can watch the video for that. All right, it's there. All right, guys. No. So I just say we are go see what can happen afterwards. But we let us stay in touch in the group now and maybe schedule another meeting to cover off these things. We have to go use some workshop time and nail off one or two of them here now that that have to happen, you know. Cause you know a serious time now. May 20. So let us stay in touch then, guys. All right.
Okay,
so-
bye, sir.
All right, bye, Kimberly.
Okay, sir. I'm going to
Alright.
send the method you here, sir.
Okay, Casey. All right.